Okay, class. So this is 8.5 solving right triangles. This is actually the like about 10 minutes after I recorded the last video. So if you haven't seen that video and you need to go ahead and watch that video first and then come back over here, you'll notice or you realize that I actually made a big whoopsie um, during that video, and it's actually quite humorous in my opinion. But here we are. And the very first thing, of course, we have a do first. Okay, just like anyway, always we should have a do first. And in this problem here, we have to figure out what x and y equal, and we're given an angle measure, and we're given the hypotenuse. X and y are the adjacent and the opposite side lengths here, so we got to figure out how to figure this out. We got to figure out how to solve those problems out. And so the very first thing I'm going to do is, well, I know that x is my opposite from my 49 degrees, and y is my adjacent from my 49 degrees, and of course, 16 is my hypotenuse. So because I'm going to solve for x first, x is the opposite, and the hypotenuse is what we have right now, so we're going to use sine. So sine of my opposite, sine of 49 degrees, can't forget that, equals my opposite, which is x, over 16. I'm just going to solve for x. X equals 16 times sine 49. And I get a value of x equaling 12.075. I don't have any units, but if you needed to, you could just write units. But here it'll be fine. Then I solve for my y here. I can do it one of two ways now. Because I know what my x is, I can use tangent and find tangent like that, or find y like that, but it's just, don't do it. Don't do it. Just don't make more work on yourself. But I could do it with our cosine because I have adjacent and I have a hypotenuse. So cosine of 49 degrees equals y over 16. I find that these problems are actually set up pretty similarly. But of course, one is cosine, one is sine. We get a y value of 10.497. Okay. Here's our key point one, inverse trig functions and whatnot, all this stuff, okay? So just like how we can undo something, let's say that something is addition, right? The way that we undo addition or the inverse of addition is subtraction. That's how we get rid of it. Same thing with multiplication and division. They are inverses of each other. Trigonometry also has inverses of their functions as well. And so for these ratios here, right, our core concept here, inverse tangent, if tangent A equals x, then tangent inverse x equals the measurement of angle A. Okay, you gotta be very careful here. Okay, -1 is not an exponent. It is not an exponent. Okay, you cannot mix that up. They are not exponents, they are inverses. Get that through your mind. Okay, you cannot confuse those for exponents. Okay. So because we have this way, we're going to use this to find our angle measures, and that's what's on the right hand side. We're going to use this to find our angle measures, and essentially what's happening here is that the angle and the ratio switch places for the inverse. That's all that's happening here. So you're going to set it up exactly the same, but then switch and inverse. And that's actually what our CFS is here. So if I look at this problem here, tangent A equals 0.75, 75, right? It's not degrees, it's just 0.75. I'm going to switch them. So tangent of 0.5 equals A. But remember, I got to inverse it. So tangent inverse, or inverse tangent, however way you want to say it, 0.75 equals A. And I actually get a value that A, the measurement rather, angle A, equals 36.9 degrees. And that's all we got to do. There is a inverse tangent function, one on Desmos for sure. On your calculators, it might be a little bit more difficult to find, but you can find it. Okay, I don't really use your calculators all that much, but if you're not sure where to find it, you can just let me know and I can find it for you. But for sure, it is in Desmos, for sure. Okay. The next one, switch. Make sure I put my inverse. So sine inverse of 0.87 equals B. And that means that the measurement of angle B is equal to 60.5 degrees. And last but not least, switch and inverse. So cosine inverse of 0.15 equals C. The measurement of angle C equals 81.4 degrees. It's not necessary. I see in the sequence here that they are all increasing. That is not the case. Okay, this is just purely coincidence. I wouldn't pay too much attention to it. Purely just coincidence. But we can use these inverse functions to be able to solve a right triangle. And to solve a right triangle just basically means to solve for all missing parts right down here. I just wrote. Okay, that's all that means. Nothing else. So you're going to solve for your angles, you're going to solve for your sides. That's all you need. Okay. But in order to solve those things, you need to find, or not find, but you need to be allowed to have either of these two things. So either two side lengths or one side length and the measure of one acute angle. Okay. Otherwise, it's impossible for you to solve. Okay. You must have one of those two things. And so here, example 2, I'm given straight up two side lengths. Super good for me. Super good. Okay. It's one of the things I need to be able to solve a right triangle. And so that's exactly what I'm going to do. I'm going to solve for C first, right? This value C. And any work associated to any of the things that I'm going to solve, I'm going to put it under, say, like this C colon here, just so that we know how to solve it. Okay. In this problem, actually much simpler than we may think. It's actually nothing really special. It's definitely something that we've seen through a lot, but realize that this is just Pythagorean theorem. I'm going to take 2 squared plus 3 squared equal to C squared. 4 plus 9 equals C squared. And C is going to equal the square root of 13. That's it. Pretty simple. For the measurement of B, in the measurement of B, right, I know I have 3 and 2. Well, now I know what C is, but C is a radical. I don't want to use a radical to solve for this stuff. Let me just use the ones that I already have. So if I'm looking at this angle B here, then I know that the 2 here is my opposite, right? Because it's directly across from my angle. And 3 is my adjacent. It's right next to my angle here. And it's not the hypotenuse. So I'm going to take the tangent of B and equal that to the opposite, which is 2, over the hypotenuse, which is 3. I'm going to do the exact same thing that I did in the previous problem, where I'm going to just take an inverse. 2 over 3 was B. Very simple. And you're going to solve. The measurement of angle B equals 33.7 degrees. And that's last but not least, but measurement of angle A. Set it up very similarly. Notice again, I still have I still have my legs, so I'm going to use tangent again. I don't want to deal with that radical. So tangent of A equals, in this case, I have 3 over 2, not 2 over 3. 3 over 2. Tangent inverse of 3 over 2 equals A. The measurement of angle A is equal to 56.3 degrees. And that's how you solve for a right triangle. Of course, like always, make sure that you try to solve some of these on your own. And then if you can't figure it out, definitely look back and see if you could get a hint somewhere, and then if that doesn't work either, then of course just watch the rest of the video. Okay, for the sake of time here, extra example 2. Again, I'm looking for these different parts. I'm looking for angle C, I'm looking for angle A, I'm looking for side AB. But notice I have 24 as a leg, 25 as a hypotenuse. I definitely have seen this. Oh, that's right. This is one of those Pythagorean triples, right? Remember, if we have a Pythagorean triple, we don't really have to do any work if we recognize it. So I know that AB, right? If AB was 7, then 7 squared plus 24 squared equals 25 squared, right? It's Pythagorean triple. And so because I have 24 as a leg and I have 25 as a hypotenuse, then AB has got to be equal to 7. Okay, just making things easier on ourselves. Very nice. Then the next one, if I'm looking for angle A, or rather, yeah, let's go with angle A. No, I'm sorry, angle C. Measurement angle C. Instead, here is the angle I'm looking at. I don't have an opposite. Well, I do have an opposite. I just solved for it, so where AB is equal to 7. But, you know, this is where it can vary. You can either go with the opposite and hypotenuse or adjacent. Really, you choose which one you think is going to be better for you, and you stick with it. If you like cosine better, go with cosine. If you like sine better, go with sine. If you like tangent better, you can use it. Okay, especially because all these 3 values are nice numbers, and they're not like decimals, they're not like radicals. Just go ahead and use whichever one you're most comfortable with. But the way that we solved it here was using cosine, because we had we had 2 pieces of information given to us, and we're using it to find our C value. And so if we did that, we had cosine of C equal to adjacent, which is 24, over hypotenuse, which is 25. You're going to switch them, inverse, cosine, inverse, let's see, 24 over 25 equals C. And you should get a value of C equals 16.3 degrees. I apologize for all that noise. The cleaning lady came in. She was as quiet as she could be. Actually pretty nice if you've never met her. Then we can solve for A. Right, we can solve it with trigonometry. Or, hear me out, we can solve it with knowing what the interior angles add up to. And if I look for the measurement angle A, I know that 180 minus 90 minus 16.3, because those are my other 2 angles, that gives me 73.7 degrees. Makes things a little bit easier on us. Okay. So, because we have all this, right, there is a writing and math opportunity, and I'll go ahead and let you go and try that out on your own. Only because I just kind of don't want to go over it right now. But I don't have it on my paper, but I think you have it on yours. And some ways to check would be, you know, you can use Pythagorean theorem to see if it works. You use Pythagorean theorem, you could use the inverse functions or the regular functions. So like the inverse trig stuff, right? If I wanted to actually solve for my measure of angle A, I could actually solve it with trigonometry. But, you know, makes things a little bit easier for us if we do it this way. But if we wanted to confirm our answers, we could go about it with the inverse functions. And those are kind of really the only ways that we could solve that, at least for right now that we know. Example 3 here. much the same. And actually the next three examples are the next example is very similar as well, where we're just solving for some of these values. And so let's go ahead and just solve for that measure of angle G. Notice I have measure of angle H, which is 25 degrees, and J, which is 90 degrees. Makes things a heck of a lot easier for us. Measure of angle G is equal to 180 minus 90 minus 25, which is going to be 65 degrees. Measure of angle G equals that. Then if I wanted to solve for my H, here you can go about it in different ways, right? You can use trigonometry again. You can use the inverse functions if you, or well, actually you can't use the inverse functions because remember, inverse functions solve for angles, but our regular trig functions will find our side lengths. So if I said, let's go for H, and if I'm going to use angle H here for 25 degrees, let's say I know H is my opposite. I know my hypotenuse, so we're going to use sine of 25, oopsies, sine of 25 degrees equals H over 13. 13 times sine 25 equals H, and H is going to equal 5.5. Easy enough. Of course, once you get your H value, you could technically solve this with Pythagorean theorem, but sometimes it gets a little bit dicey, especially with our sine, because sine doesn't always go to a perfect number. Neither does cosine or tangent. They don't always go to perfect numbers. And I'm going to assume that this is no different. It's probably just rounded. But actually it is. Look, see, maybe instead of 10. It actually is rounded. So I would just be careful with that. Just use the values that you currently have. And so if I'm looking for G, right, and I'm still using that angle H, I'm going to use 25 degrees, but now I'm going to use cosine equals G, which is my adjacent, over my 13, which is the hypotenuse. And again, it's pretty much cut and dry the exact same thing that we did. We get G equals 11.8. Again, all pretty simple stuff. Just a lot of time I find that we have troubles with recognition, and by far is the worst thing that we can possibly do. I'm not sure why, but that's just how it is. So trying the best I can to help you recognize these things, but I'm not sure how to help everybody. But I'm trying, definitely trying. Okay, so after that, we have the exact same problem again. Try it on your own first, see if you can solve it. If not, come back, get to a point where you can understand a little bit more, and then try it again, And we're not going to progress as people, as students, if we don't reflect on ourselves and be able to figure things out and whatnot. So let's just go ahead and try to solve this. We'll just start with the measurement of y first. And of course, I already know. Think back to, I don't know, I think it was Unit 5 when we introduced this, where if we already have a right if we have a right triangle, then the other two angles, that's not the right angle, equal to 90. So I'm going to take 90 minus 41, and I'm going to get an answer of 49 degrees for my y. Pretty easy. Then we're going to solve for my x next. Here, if I'm using angle x, I know x is my opposite. I know my hypotenuse, which is 18.4. So I'm going to use sine of 41 equals x, my opposite, over 18.4, which is my hypotenuse. And I'm just going to solve. 18.4 times sine 41 equals x. And we'll find that x equals 11.8, which, funnily enough, is the exact same answer as one of the previous problems. But interesting. Definitely a coincidence. Wouldn't read too far into it. Then we'll solve for y, do the exact same approach, right? 41 degrees, y is the adjacent. I also still have my hypotenuse. So we'll use cosine 41 equals my y over my 18.4. And look at that, pretty much the exact same thing. I get y equals 13.9. And all is good. All is good. Lastly, I don't know why, but for whatever reason, T is not on your paper. It wasn't on my paper, at least. So you're at the right end, your own T. T is for YZ, though. And I'm not sure why they have this problem really at the end of this. It just kind of seems like a throwaway problem. Because I feel like this would have been more useful like for the very first lesson, but you know, here we are. Right. And so here I look at this problem and I said, well, I know I am looking at this angle 52 degrees. This is my opposite, that's my T. And then 8.5, that is adjacent. And I don't know what my hypotenuse is. I have no idea. I don't care about it. I'm not looking for it. I'm looking for T. And so because I'm looking for T, I have my opposite. I have my adjacent. I'm going to use tangent. So tangent of 52 degrees equals opposite, which is T, over adjacent, which is 8.5. And I'm just going to solve. Again, really not a whole lot that's really sort of difficult. But I'll get a T value of 10.9. And you know what? That is the very last lesson of Unit 8. And whew, it's been a long day. Y'all just took an exam, and I just stayed an hour and a half after school to record these videos. And the first one I did was kind of botched by a lot. But you know what? I'm not going to record another one. I'm not going to record another one because I don't want to. But this is the entire unit. After this lesson is done, we are prepping for our common assessment review, which is to be determined. But you know what? We are going to keep trudging along. We still have that common assessment to do, and we're going to do the best that we can to make sure that we're prepared. So as long as you're watching these videos, as long as I'm still making these videos, and you're doing all the work that we're supposed to be doing in class, I really don't think you're going to do bad. I think you'll be fine, actually. But of course, growth is a lot better than staying where you are. So make sure you're growing and not just falling behind. Okay. Alrighty then. Then that is the end of this lesson. I will talk to you all later. Again, you want to make sure that you're studying, especially with that common assessment. 5% of your semester grade could be a really good thing or a really bad thing. But I will see you. Goodbye.